Cables. Invisible but necessary. What are they made from? How do we get a copper wire into a plastic tube? Most people don't know. Actually, they don't need to. What they only need to know is that we, ELKOND, have our own know-how. The basic material for production of metal cables is the copper rod with 8mm diameter. The first step in process of cable production is a gradual reduction of the rod diameter to a requested thickness using drawing machine. We recognize 3 types of drawing machines depending on resulting product: rod breakdown drawing machine, intermediate wire drawing machine, and fine wire drawing machine. The rod breakdown machine reduces the 8mm rod to a new diameter between 4 and 1mm. After unwinding by the payoff machine, wire gets to drawing pulleys where it is gradually drawn through calibration dies. To keep the wire surface homogeneous, an emulsion is injected into drawing rod, which acts also as cooling. During drawing, the wire could become hard and thus unusable. To avoid this, the wire is annealed. The resulting wire is coiled into baskets. Next drawing machine is the intermediate wire drawing machine, where the thickness is reduced to diameters between 1.5 and 0.4mm. The principle is identical with rod breakdown drawing process. Wire with requested diameter is being wound into baskets or on reels. To draw finest wires, we use a fine wire drawing machine, which produces copper wires in diameters between 0.5 and 0.1mm. To improve the production process efficiency, ELKOND can draw multiple wires simultaneously using multi-wire drawing. This technology allows us to draw 8 wires at the same time, resulting in 8 times higher efficiency. Wires are drawn by a system of pulleys through calibration dies. The wire surface homogeneity and cooling is again ensured by an emulsion. Hardening of the wire is prevented by continuously annealing. Wires are cooled down again and a bundle of 8 wires is being stored on technical reels. In cables, 2 types of cores can be used. For fixed installation, for example into a wall, we use cables with solid wire cores. In case of flexible cables, for example in lawnmowers, we use copper strands consisting of multiple wires. Depending on diameter and flexibility, class of such rope, these are twisted into regular or irregular constructions. In ropes with regular twisting, single layers are twisted in direction opposite to the previous layer. One of the options is use of a system of baskets. In ELKOND, we can produce a rope with cross-section up to 1,500 mm square, consisting of 2,989 wires. In the last step, the rope is wrapped into a protective foil. For production of fire-resistant cables, we use mica tape. This treatment is done on so-called overlapping taping machines, where the tape is overlapped around the copper wire. In fire, this mica tape prevents short circuit and the powered devices remains active also during fire. The protective element on cable cores is insulation. This insulation is applied on specialized insulation lines, where under high pressure and temperature the conductor is covered by molten compound. Machines at the beginning of the insulation line ensure delivery of materials for production of the wire. This includes the preheated copper wire, insulation materials, and master batches. These are delivered in form of granules. Insulation materials and other ingredients are mixed in proper ratio to create a compound. This compound is melted in an extruder and then delivered through a screw and barrel into the extrusion head, which applies it onto the preheated wire. After this process, the insulated core is being cooled down in a cooling through, followed by a count meter device, diameter measuring device, and spark tester to check the homogeneity and continuity of the insulation. All parts of the installation line and the whole process is being monitored and recorded by an industrial computer with subsequent visualization. All operations and semi-products of the production process are recorded by a barcode scanner into our information system. Third party of the cable production is arranging individual wires into cable core. Operations of this phase are done by stranding machines. Multiple payoff machines at the beginning of the line unwind wires from baskets or coils. Wires enter a stranding machine where they are stranded into subgroups and finally into a cable core. Variants of cable core are specified by standards that define color and arrangements of wires. The line has also additional machines that apply various protective and screening tapes. Some of our cables consist of up to 400 stranded wires. Production of cable cores can be done in various ways: regular stranding, stranding into subgroups, and consequent merge in layers, also called SZ stranding, where the stranding direction is being altered in regular cycles. Stranding method is chosen depending on requested parameters and intended purpose of the cable. An important step in production of certain cables is screening. There are several types of screening materials. Most common are aluminium and copper tapes, which are being applied to the cable on taping machines. Use of a copper tape protecting from electromagnetic fields is typical for the energy sector. One of screening method is braiding with fine tinned copper wires. These fine wires create a braid with optical density between 50 and 100%. This type of screening is used mainly for cables with increased protection against electromagnetic interference. Prepared cable cores go to the final phase, coating. The principle is similar to insulating process and done on specialized coating lines. Optimization of this production process is very important in terms of costs. An undisputable advantage is that for production of some cable types, we use coating lines that include also a stranding machine. One line does stranding of insulated wires, screening by a tape, and applies final protective coating. The coating itself is done by extrusion heads where the melted compound is applied to the cable core. The outside coat has several functions. It protects the conductors from effects of weather, UV radiation, and mechanical damage. In self-support aerial cables, we use steel bearing rope. After applying the outside coat and subsequent quick cooling, the outside diameter is checked by a laser, followed by a spark tester that verifies the coat integrity. A certified count meter device measures the length of the cable. In the last step, the cable is marked with description and length data. This is done by a contactless color printer. The whole process is controlled and monitored by an industrial computer, and the operator has individual settings visualized. At the end of the coating line, the completed cables are put on requested transport packaging by a take-up machine with compensator. Most common packaging types are metal or wooden drums and plywood drums, but cables are being delivered also in coils. If required by the customer, these coils can be wrapped into a protective foil. In addition to input quality control of materials for production and measurements during production process, we check parameters of final cables also by output quality control. These measurements assure that faulty products won't leave our gates. In ELKOND, we test cables for mechanical properties, conductor resistance, insulation, and coat thickness. Chemical laboratory is used for special tests, such as corrosive resistance. The spark tester verifies quality of conductor insulation by multiple voltage overload. The measuring station evaluates electrical parameters of cables. All results are noted to a measurement protocol. Drums and coils stored on pallets are transferred to warehouses and waiting for dispatch. Cables resistant to weather influences are stored in the external area.